Hi guys, hello and welcome to another C# tutorial. In this tutorial, we will learn about the shortcut operators and other arithmetic operators available to you in C#. I have a variable declared called age of data type integer, and the value stored in the variable is 16. If I were to display the output of this variable, it will display 16. Let me put a read instruction to hold the screen temporarily. And now let's run it to see what the output of this program comes out. And you will see that it says the current age is 16, and that's exactly what the age is. If I were to increment the age by 1, typically speaking, if you know a little bit of algebra, and let's assume the age is a variable x, you will say x equals to x plus 1. That's exactly how you will increment the value of age by 1, by simply adding 1 to the existing value of age. So based on this formula, if I take this approach, this is one of the 4 approaches I want to introduce to you today, how to increment the value of a variable by 1, you will now see that yes, age is equals to age plus 1, modeled after the same idea as you see over here on line number 17 in the comment. And now let's try to print the age. And since the previous value of age was 16, the new value of age must be 17. Let's run this program to see how the output comes out. And you can see the age was incremented by 1, and the new value is 17. Let's learn about the second approach. It's called the post-increment approach. It is traditionally written out as age plus plus, which is a post-increment because the plus plus operator is right after the age variable, and it increments the value of age by 1. It is more of a shortcut variable, and again we will increment the value of age by 1 and display the outputs. The age must come out to be 18 years after this one. So as you can see in the output, the age is now 18 because of age plus plus. Now let's look at the third approach, which is called the pre-increment operator, which is plus plus age. So you write the plus plus operator, however you write it before the variable, and that's called the pre-increment operator. And we will now going to look at how the code looks like. So you have a pre-increment operator, age plus plus. This is my third approach to increment the value. Okay, now let's run it to see that age is now 19 years old. Okay, now so the 3 ways are done. Now let's look at the fourth approach. Traditionally speaking, you will write x equals to x plus 1. So now I am about to introduce to you a shortcut operator of this existing algebraic expression that you already told me in common line number 17, or I told you x equals to x plus 1. Since the same variable gets to repeat on both sides of equals to, you can shorten the logic by combining plus and equals to together and increment it by 1. That's a shortcut operator. If the same variable gets to be repeated on both sides, you could take this approach, and this will increment the value by 1. Okay, so let's model our next expression after this approach. So it will going to be x plus equals to 1, right? This is our fourth approach. Okay, now that this approach is in front of you, you probably must be wondering, well, when should I pick first approach? First approach is traditionally picked if the variable on the left is not repeated on the right. So if it is, let's say, x equals to y plus 2. So the variables are different. So you'll take that first approach. Second and third approach are interchangeable in this case, but not always. I'll show you the cases when they are not the same. And then the fourth approach is traditionally used if you want to increment by more than 1, or if you want to decrement by anything other than, 1. So if you are incrementing by 1 or decrementing by 1, you can certainly use h plus plus to increment and h minus minus to decrement by 1. However, this approach is traditionally used if I want to increment by, let's say, negative 10. So I can say h plus equals to negative 10. Or if I want to increment by a positive value like 100, so I can say h plus equals to 100. So it will be equivalent to saying h equals to h plus 100. So that approach can be taken in that regards. Now let's test this after this approach number 4, and you see that the person is now 20 years old. Now let's see the difference between when we use the plus age operator right inside the program logic, right inside the output instruction. So here, as you can see, I'm using plus age right within the output instruction. In this case, if I run it, the output will be 21 because it is pre-increment. What does that mean? It will first increment the value of age by 1. It was 20, will now become 21, and will now display its value. So the age value comes out to be 21. However, if I change the value of age by using a post-increment operator, age plus, the output will still come out to be 21, and the reason is this is a post increment. What does that mean? It will first give out its existing value to the output, which is 21, and will then increment by 1 and will become 22. However, the output will still say 21. Now let's test to see if the age really changed, and you will be able to see that the age will change to 21. So if you look at my next instruction, in the next instruction, I'm simply displaying the existing value of age without doing any increments to it, and it tells me that the age is 22. So I hope you understood how you can go about incrementing the values of a variable using any of these many approaches, and how pre and post increment operators make a difference to a variable. Very similarly, you can have decrement operators. You can decrement the value of a variable by 1 by simply doing either age minus or minus age, or age minus equals to 1. So now, since I am writing all these instructions in a row, I'm decrementing the value of age by 3, because the first one will bring it down by 1, the second one will going to bring it down by another 1, and the third one will going to bring it down with 1 more value. So now the value should be 22 minus 3, which will be 19. So 19 will be the value printed for the age. Let's test this. So you can see that it is 19 years after the decrement of 3. So as you can see over here, that we can decrement by a value anything other than 1 as well. So let's say if I want to decrement this by 5 instead of 1. So this should be a decrement of 7, because line 35 decrements by 1, line 36 decrements by another 1, and then line number 37 decrements by another 1. So that is 7. So 22 minus 7 is 15. So now the person is 15 years old. So that's how you can be using the increment and the decrement variables. Now we do not have age multiply, because anything multiplied by 1 is 1. We don't have age divide because anything divided by 1 is also 1. But we do have age multiply equals to a value. So if I say age times equals to 2, age times equals to 2, so that means the current value of age multiplied by 2, which will be 15 times 2, 30, and store it back in age. So let's see what this output comes out to be, and you can see that the age is 30 years old. Similarly, I can divide the age by 2, so it will be, again, when you divide a 30 by 2, you should get 15. So let's try to run this again, and you will going to get the age to be 15 again. Let me update the comments. So the age after this one will be 30, and now it will be brought back to 15, and this is where the age is 15. So this is how you have multiply equals to, divide equals to. Very similarly, you can also have modulus equals to, which is the remainder after the division takes place. Anyway, this short 10 minutes tutorial must have helped you understand these operators. If you have any questions, don't forget to write in the comment section below. And if you have any suggestions for any kind of videos, let me know, and I'll be more than happy to create a tutorial for you on that subject matter. Take care. Don't forget to like, share, subscribe to my channel. Take care. Bye-bye.